welcome everybody to the first session after the keynote of day one of Cloud Next 18. We're very excited to have you all here. We appreciate a lot of you have traveled pretty far, made a lot of effort to get here, and we hope that we're able to bring you a lot of value and improve your day-to-day developer lives. Before we get started, I think people are still trickling in, so one of the things that you're going to see new this year at Next is we're trying out a little something different for the Q&A session. So some of the larger sessions like this one are going to use actually the same internal Q&A system that we use at Google for all of our large get-togethers. It's called Dory. And if you have the mobile app or website and you go to this session, you'll see a link called the Dory Q&A. If you click that, you're actually going to be able to submit questions throughout the talk and vote on other people's questions so that when we get to the Q&A session at the end, we make sure that we answer the questions that kind of are of the most interest to people. And we'll have mics as well for people that want to ask questions that way, but we encourage you to kind of check that out and sort of experiment, or dog food as we like to say, with us. So we're here today to talk about CI/CD in a serverless world, CI/CD, continuous integration, and continuous delivery. Serverless is going to be one of the themes that you've heard about already this morning. You're going to hear about over the course of the 3 days. And serverless is I think it's really exciting. It's definitely one of the newer areas of cloud and computing. And developer tools around serverless and best practices around that are even more immature. So we're going to talk about some of the solutions that we offer on Google Cloud and some of the best practices and successful techniques that we've seen in order to run serverless workloads in a production environment. My name is Christopher Sanson. I'm a product manager at Google. Based out of New York City, I work on CI/CD solutions and developer tooling in general. We actually have an encore session of this talk. It reached full enrollment, so if you know anyone who's interested that wasn't able to make it in, we're going to have an encore session of this on Thursday over in the Metreon next door. So I assume many of you just came from the keynote. If you did, you may have seen the presentation around a new business venture that I think Ors was thinking about starting called the Hipster Store. You can buy things like old cameras, I think, fixie bikes, things like that. But at Google, we're all about sort of openness, open platform, togetherness. So, the Hipster Store didn't really speak to me as a consumer. So if you're not really interested in that, I'm actually going to start a competing store. It's called the Prepster Shop. So we're going to sell things like boat shoes and blazers. Anything with like an anchor or a lobster on it, is available for you there. But one big difference between the Hipster Shop and the Prepster Shop is that mine's entirely serverless. So my front end is running on Firebase hosting, my back end is running on App Engine, and I'm using Cloud Functions as sort of glue code to wrap business logic around it. And later on, we're going to do a demo to talk about a little bit how this is architected and go through kind of the day in the life of a developer as I push changes out to production. But before we get into that, I want to step back just for a second and sort of set the stage a little bit and sort of kind of define serverless as how we define it here. Serverless is one of those words that's kind of like DevOps or CI itself, where depending on the context, it means different things to different people. The way that we're going to use serverless is really applications and services that you don't really have to think too much about what they're running on top of. So the idea is that you could just bring your source code, and you don't have to think about versioning or patching or provisioning or scaling, and all of that is really done for you. The first thing that typically comes to mind when you hear serverless is functions, and rightfully so. But we definitely see serverless as a much broader ecosystem than that. We think it includes things like AI and databases and data warehousing. And on Google Cloud, we actually offer serverless solutions in each of those different categories. But when we talk about developer solutions in CI/CD, we're really mainly focused on serverless compute. And when we talk about serverless compute, there are really kind of three primary solutions. Google Cloud Functions, which is relatively new. Google App Engine, which launched 10 years ago this year as one of sort of the pioneers when it comes to serverless. And Firebase, which is kind of part of the extended family of the Google Cloud Platform. So that's sort of how we're going to talk about serverless itself. So when we talk about CI/CD for serverless, what do we mean exactly? If you're running CI systems now or you've built your own, you might recognize some of these terms. You deal with things like configuration management, batch jobs, maybe ugly things like nested virtualization if you're trying to run emulators for Android. Well, these are definitely all the things that we do not want to worry about anymore, right? We want all of these problems to go away. I don't want to have to think about having to bake an immutable image to deploy out to my cloud infrastructure. the whole point of serverless is to kind of move these infrastructure pieces below the waterline so that your developers can focus on source code and not sort of this underlying infrastructure. It would be a real shame if we were able to move to serverless and then our developers had to like provision a build agent and configure it to run their builds. So what do we mean for CI/CD for serverless? Well, it's all the best pieces of CI/CD in the first place that helps us lower our mean time to release, reduce human error, deploy faster and safer. And for us, that primarily revolves around automation. So as a developer, I want to sit in my chair, drink my iced tea, do a get push, and then have everything just sort of magically deploy out to production for me. And along the way, we're going to have to do a couple steps to our code to get it there. We might not be compiling code, but we're probably going to be packaging up with something like Webpack or something like that. We're definitely going to want to automate all of our unit and integration tests. We all have sort of 80, 90% test coverage on our applications, of course, so we're going to want to make sure we take advantage of that. We're also going to want to have a manual review process. So if you're familiar with the conversation between what's continuous delivery and what's continuous deployment, and the difference being that there's usually a manual approval step, in the real world, almost every change has to be reviewed by somebody before it goes out, right? Whether it's sort of a product owner or management or design team, we're going to want to bake that into our process that somebody can sort of look at and say, okay, this looks good. This is what we had in mind. We're also going to take advantage of some of the best practices around continuous delivery, so things like blue-green deployments and canary. And this is really to reduce downtime to our users and also minimize the blast radius of any errors that do get out. Like, we're not going to want to deploy something to 100% of users right away. We're going to canary it out gradually, sort of 5%, 10% at a time. The last couple, as we go through these, we're going to want to automate related tasks, so things like creating documentation and stuff that we often tend to forget. And the last is consistent build environments. And this is just a general best practice around developer tools. I think we all know the phenomenon of sort of building locally and then building in the cloud and not having those two match up and trying to figure out why. So if we look at this kind of flow chart, this probably looks familiar to most of you. This is sort of a classic software delivery lifecycle chart. As a developer, I'm going to do a get push. My source code is then going to get packaged and tested and then deployed to a staging environment. From there, we're going to have a chance to review and promote that to production and ultimately deliver it to our users. So when we talk about CI/CD, it's definitely more of a spectrum. It's more of a staircase than it is like a light switch. We did a recent research asking people, do you practice CI/CD? And one of the questions is, do you practice true CI and true CD? And only about 15% of organizations said they did. The vast majority were self-described as sort of, we do kind of almost CI/CD. We sort of do true CD, but we sort of almost do CI. We kind of fake it around the edges. So what we find is that most companies who are trying to move towards full end-to-end automation are still in that journey and still getting there. So if we look at kind of the basic, and this is in red because this isn't really even part of CI/CD, but particularly in the context of serverless, we're tempted to do manual deployments. If I'm changing a single file or changing an HTML file, what's the big deal? I can just run a deploy script. I can go to my terminal. Most of these have really powerful CLI tools. I can just manually deploy. But pretty quickly as a developer, I hit a wall with that. If I have any sort of team that's developing together on a source repo, if I want to reduce errors, I'm going to want to sort of step up my game. And so particularly in the context of CI/CD, what we see is that a lot of the services more and more frequently are coming with baked-in smarts. So a lot of the best practices, like things like traffic splitting, that we had to sort of create ourselves and code, are coming as baked-in features of the platform itself. I think what we're going to see over time is that more and more of these best practices come supported out of the box, so that every time you do a deployment, you can provide the test script to run. You can tell the branch of your repo that you want to trigger. But we're not really there yet. So I think, as we said, serverless tools are still relatively new. It's still an evolving space. So this is definitely where we're going to go. But in terms of building a pipeline, we can't really do it quite yet. So the next step up is what I kind of think of as dev-centric CI/CD. And so in this world, it's very developer-focused. As a developer, I want to live in my source code. I want to live in my code editor. I want to live at the terminal. I want to make changes. And then again, I want my changes to go out to production. Services like in this kind of category, they're generally hosted. They're generally pretty easy to use. And in this world, I really view my repo as my source of truth. I want to be able to go to my Git repo and get a pretty good sense of what users are seeing at each stage of the environment. And the final step on the ladder is kind of ops-centric CI/CD. So as we talk to customers, particularly larger ones and enterprises, the dev-centric model tends to fall over at some point. So larger customers tend to be they have very complex and heterogeneous footprints, and they're always kind of migrating between multiple services. So they may have some sort of legacy platform that's running on-prem. They're probably deploying to multiple clouds. They may be deploying to Kubernetes and VMs and Windows and Linux and iOS. And operators who are trying to put out fires all the time, really they just want like a single pane of glass view across all of these different deployments. And they also want to enforce compliance as well. They want to have that bottleneck so that they can enforce security and compliance rules across deployments everywhere. And in that category, if you're familiar, sort of worked with Google, you may have heard about Spinnaker. I know many of you here are actually using it already. Spinnaker is an open source multi-cloud continuous delivery platform. It's co-developed by Google and Netflix. And we have a couple great talks that really dive deeper into that this week. Target is giving one. Netflix is actually here as well. They're giving a talk with Waze about how they use Spinnaker. But for the purpose of this talk, we're really going to focus on the dev-centric experience. And because we're talking about serverless, the lines between these categories blur even more. We sort of talked about, like, we want to kind of hide the operations piece from our developers. And serverless really lets us do that. So we really want to achieve kind of full automation from the source repo. So I think our first takeaway is, I hope we all sort of appreciate, I imagine we're here in the room because we generally agree on this, is that you absolutely still need CI/CD solutions built around this. And so at Google, this is sort of what we're excited to announce. So this week, and earlier this morning, you heard that we announced Cloud Build. So Google Cloud Build is a hosted CI/CD platform running on Google Cloud for automating your developer workloads. And this is actually an evolution of another Google product, Container Builder. So to give a brief history, if you're familiar with Container Builder, we launched this a year ago at GCP Next 17 as a way to build Docker images quickly and easily. You could point it at a repo and do a git push, and we would upload your source code to a VM in the cloud that we managed, do a Docker build, and push that out to container registry. But from the very beginning, the way we architected this, we sort of had grander visions. We thought, there's a lot more we can do with this than just build containers. We can really apply this to not only containers, but sort of other workflows as well. So let's take a look at kind of how a workflow at Cloud Build actually works, and we can sort of talk a little bit how about it applies to serverless. So we start kind of, as we always do, with source code. And in the case of containers, we end up with a built image in the container registry. And along the way, we upload your source code to the cloud, to Google, and we put it in a shared file system. And against that workspace, we're going to run a series of build steps. So build steps are the naming convention that Cloud Build uses. It's sort of like stages or jobs, if you're familiar with that from other CI solutions. And in the context of containers, you may do things like this. You may do a Docker pull to fetch a previously built image. You may fetch some dependencies, do a Docker build, and then push that out to the registry. But sort of the key takeaway or the key way to look at Cloud Build and why it's different is that these build steps are actually just containers themselves. So everything that happens in a Cloud Build is a containerized task that's completely isolated and completely defined by you as the user. So because of that, people pretty quickly with Container Builder said, hey, wait a minute, I can do a lot more. I can run all sorts of different things in a container. And so very quickly, they started doing things like building other types of artifacts. So they were doing Gradle and Maven builds to build tarballs and binaries, pushing that up to cloud storage. They started running tests. You could run arbitrary bash scripts. You can do curl, things like even Docker Compose. Kubernetes users said, well, I built the image and I have it on my worker. Instead of pushing to a registry, can I just kind of do a GitOps model? Can I use kubectl or Helm to apply that out to the cluster? And they started using it that way. And I think what we also saw, and the reason we're here, is that it works really great for serverless applications. And that's because I think one of the coolest parts about serverless is that almost all of the best services come with really great CLI tools. So things like, sure, gcloud and Firebase, but even throughout the ecosystem, things like Netlify and Surge and Webtask, they all come with really powerful CLIs that really naturally sort of extend themselves into containerized workloads. And so what you could do is not only build and test your code, but also deploy it out to serverless. We call these things builder images, and these are the actual containerized tasks that you can use to run your different workloads. And these are all open source, and you can, of course, bring your own. I think we have around 40 or 50 that are contributed by the community, and people have done all sorts of things. We have some for .NET. There's an Android builder. There's Packer. There's Hugo. You name it, and just about anything can be run as a container task. So the second takeaway is that not only do we really want to still do CI/CD for serverless, but that you can use Cloud Build as well for that solution. And in fact, that's actually exactly what we're going to do. So let's switch back over to our demo, and we're going to look at the Prepster store here and see if we can't sort of go through a couple real-world examples of actually making changes and then deploying this out. So if we could switch to the demo. Great, thank you. So let's look at our site here. So this is our Prepster shop. This is live and up on the web and ready for business. And what we did is we created two environments. So we created, first we created a staging environment, both on Firebase, which is here, and a production environment. And all of our changes before hitting prod are going to pass through our staging environment. And if we look at our source repo, we'll see that we are using kind of a small mono repo. So obviously we could use microservices, but for the sake of keeping things simple, we decided to put everything in one place. So we have a backend folder here, which is an App Engine app, front end running on Firebase and Cloud Functions. So the site is, looking pretty good to me. But I got in on the morning, I'm enjoying my first cup of coffee, and the design team comes running over, and they say, hey, look, the site looks really great. We really like this header bar, but we really need to update it. The red color, it's looking a little stale. We really want to turn this to green. So I said, sure, that is no problem. So I'm going to go back here to my source code, go into the front end. This is an AngularJS app. Go into source, find the CSS file where that's defined, and make my change. So it's here red. Let's make it green. Commit that. So I'm going to commit that in. I'm now going to jump over to the Cloud Build UI. So this is the Cloud Build UI in Cloud Console. This is now a top-level service, so you'll find it directly under Tools, and it's no longer nested under Container Registry, if you're familiar with that. And if I hit refresh, I'll see that a new build was kicked off. So if I jump into that build, we can take a look at what's happening. So this build was kicked off by my trigger, deploy front end to staging. It's in progress. I'm using some encrypted secrets for my Firebase token for my ultimate deployment to Firebase. And I'm going to run a series of build steps here. So first, I'm going to install my node modules using npm install. And then I'm going to do a simple build using npm run build. And then I'm just going to deploy it out with the regular Firebase CLI, doing Firebase deploy to my staging environment. And if I look at the trigger that set this up, I'll go over here. So this is the trigger. It's a Cloud Build trigger, and this is what the logic that looks for events on my repo and then kicks off the pipeline that I created. So for this one, I'm going to listen to changes on my staging branch, and only changes that happen in my front-end directory. So you saw that we set it up as a mono repo. If I make a change to my backend, I don't want to rebuild and deploy my front end, right? I only want to deploy changes that are relevant. So this is a new feature of Cloud Build that's available as of today. We call it file path triggering, and it lets you filter triggers basically on files that change. So we're going to look for changes in our front end folder, and we're actually going to ignore some other files. So if I change the README or a get ignore, I don't want to trigger a build on that either, so we're going to ignore any changes to those. And then when that happens, we're just going to use our cloudbuild.yaml to configure our build. So if I go back over here to the build, check in on the progress, and I fight the Wi-Fi, we'll see that, OK, the build is successfully completed. And if I go back to my staging app and refresh, sure enough, we see that my change was successfully deployed. So I talk to the design team. I say, does this look good? They say, yep, looks great. So I'm going to go back to my Git repo here. Looks like GitHub was nice enough to recommend the pull request for me. I'm going to create this, and what I'm going to do now to promote it to production is simply merge it into my master branch. So I'm going to merge this, confirm. Great. So now this change was on my master. And I'm obviously working from the UI here, just so I don't have to go through the full workflow. But obviously, from your terminal, you can do a git commit and get push to invoke this as well, or use plugins with your code editor. And if I go back to Cloud Build, I'll see another build has been kicked off, which again will do more or less the same steps, but this time we're deploying to production instead. So if we look at the cloud build.yaml to get a bit better sense of exactly how we set this up, so let's go to front end, look at the cloud build.yaml that executed. We're going to see more or less the same build steps that we saw before. So this first one, we're installing our node modules. This is the containerized task that we're running. So we're going to use npm, and we're going to pass in our arguments and just run npm install. And we're going to do this in the front end directory. We have a couple other steps for linting and code testing that we're just commenting out for the sake of the demo, but we would probably run these as well. We're then going to build with npm run build, and then simply deploy with Firebase. And it comes with built-in support for KMS, which is key management service, so that you can encrypt your tokens to talk to third-party services. So if we go back to the build, one other thing that you might have noticed, if you're using Container Builder that you haven't seen yet, is view this build in the new build result interface. So if we click on that, and fight the Wi-Fi. Whoa, whoa. That is not a feature. The demo gods were kind. Here we go. So this is our new build result UI. And you can see that we're running the same build that we ran before. So we have steps where we install our node modules, run our builds, and deploy. And this is currently in private alpha, but this is going to be rolling out later this year. And what we heard from users over and over was that the UI is really great, but as a developer, I really want to be able to debug my builds quickly and also have more kind of a dashboard view of what the status of my different deployed applications are. So we're building a new UI from scratch to help sort of enable that. So if I look here, it says that it looks like this build was successful. And if I go back to production here and refresh, sure enough, my change is out, and I'm done. So I send a Slack message to the design team. It says, good news, our changes are live. So I'm feeling good. I'm going back to my coffee. And before I can relax too much, I see the sales team runs over. The sales team runs over and says, hey, Christopher, good news, bad news. The good news is the linen blazer has been extremely popular. The bad news is that we're sold out. So we don't have any left. And can we update the database to sort of indicate that to so that we don't get any more orders before we get more in? So we say, sure, no problem. So for that, we're going to jump into our backend. So if we go back to our repo here, this is just a regular App Engine app. We've created two versions of it, one for staging, which we're going to deploy to our staging service, and one to production, which we're just going to use our default. And if we jump into our app.js, and find out where our API response is coming from. This is our fancy inventory management service here. Turn this to true. Commit that to staging. There we go. And if we go back to Cloud Build again and refresh, we'll see that a new build has been kicked off. This one is triggered on deploy backend to staging. So again, we're looking only for changes to our backend folder. And this one's pretty simple. We're just running basically a G-Cloud app deploy to our staging service. One thing that's interesting that you'll notice here is that we're actually going to pass in a version ID. So if you're familiar with App Engine, if you don't specify one, App Engine will provide you with a unique ID. But it doesn't really tell you much about what was actually deployed. So we're actually going to pass in the commit SHA as our ID to all of our App Engine deployments. And this way, if we go to our App Engine interface and want to sort of understand what's in production or what's on staging, we can really quickly and easily map it back to the commit SHA so we know exactly what source code was in there. So if we let that change go out, looks like the build is completing, and it's done. We'll go over here. Refresh. And let's see, App Engine can be fairly efficient with its caching sometimes. So if I go to the API response and give that a chance to refresh here. And OK, so sold out is true. So we should see that as well on our front end now. And we do. So our linen blazer here is transferred to sold out. And I can no longer buy it. Looks good to me. It's a pretty straightforward change. So let's do the same trick we did before. Let's go back to our code repo. Let's merge this into master. and push that out. And so for our push to production, we're actually going to do a little something different. So we talked earlier around how we want to canary changes out to users and not necessarily deploy them to 100% of people all at once. And if we go in here to our build, and we look at the build steps that ran, we're doing some more things here. So let's look at our cloud-build.yaml and sort of investigate a little further out what's going on. So we're going to go to our cloud-build.yaml for production. And what we're going to do is actually, so the way App Engine works is that when you do a deployment and you give it your source code, it actually builds a container under the hood using Cloud Build itself, and then deploys that container out. So when we're deploying to production, we're actually going to do this process ourselves manually. Instead of deploying source code, we're going to build the container ahead of time and then pass that in. So this way, I actually now have an artifact of what was released at any time. So if anything ever goes wrong in production, I could pull that container down and run it locally. I can also use it for things like integration tests and smoke tests and things like that. So we're going to do npm test. We're going to do docker build. And then we're going to use the image URL flag to deploy that out to App Engine. The other thing that we're going to do is we're actually going to canary this change out. So we're going to use the no promote flag to deploy the version, but not actually send any traffic over yet. And what we're going to do here is we're going to actually do a little bash, little scripting here. So everything we've done so far has been pretty straightforward, like Firebase deploy, gcloud app deploy. For canarying out, we're going to jump into bash. So this is a container. I can just set my entry point to anything I want. And we're going to grab the version that users are currently seeing. So we're going to do gcloud app versions list, sort it by the amount of traffic that it's getting, and just grab the first one. We're then going to have a really very pretty Python script to grab that version ID, and then use the gcloud set traffic field to programmatically canary this change out. And what we're going to do is we're going to take the version that we just deployed, which we tagged with the commit SHA, and give that 5%. We're then going to take the version that's currently getting traffic and give that 95%. And so if we go over to App Engine here and hit refresh, sure enough, we'll see that the build that we just did is currently being rolled out to 5% of our users. And what's great is that App Engine comes baked in with things like traffic splitting. So we can go in here and then, assuming things look good, roll this out as we see fit. So we're just going to roll it out to 100%. So that was saved successfully. And if we go back, we'll see that we have successfully sort of canaried this change out. So let's take a change. Let's just confirm here that that actually worked. Yep, and sure enough, it's in production and live. Whew. All right, so if we take a little breath and just look at everything we just accomplished, with just a couple changes to our Git repo, we're able to stage and deploy changes to both our front end and our back end. And if you notice, like we were jumping around in the UI to sort of show you what was going on behind the scenes, but really as a developer, I never really had to leave my code editor. I could just do all this from the terminal. I could do all this from GitHub or the source repository that you're using, and just push those changes out and not have to worry about anything. So we're feeling pretty good. I was going to take a break, but I see the CEO is running over. The CEO comes over, and we had previously set up an alert. So every time we made a large sale as a startup, we're very excited, we set it up so that she gets a text message, so that she got this gong in the office, and she likes, like every time we have a big sale, she likes to go and ring the gong and sort of celebrate. Turns out she got a new phone number over the weekend, and really needs us to update where we're sending those text messages to. So for that, we're going to jump back into our code and go into Cloud Functions. So Cloud Functions is definitely one of the things that we hear from customers the most about sort of how do I run functions or manage functions at scale? Like when I have one function or two functions, it's pretty straightforward, but if I start getting 50 or 100, how can I automate this in a safe way? I don't want to have to manually update my index.js file every time I create a new one, and I don't want to deploy all my functions every single time I make a change. So we're going to do a couple things via convention and a couple things via technology here to make sure that this works. So the first thing we're going to do is we're going to put our functions in this functions folder here. And so these are our functions. On large sale is the one we care about, but we have a whole bunch. So we have auth, login, logout, user, on create, on delete. And if you notice that we added an extension here to each one of these .f.js, and this is going to let us do some kind of fancy stuff. So if we go to our index.js file, we're going to do a couple tricks here. Some you may be familiar with, some may be new. So the way functions works is that it looks for exported functions in your index.js file. And what we're going to do is actually glob over that functions folder, grab every file that ends in f.js, and then we're going to loop over it and convert that file path to a function name. So in the case of auth.onCreate, we're going to convert that to a camel-cased function name called auth.onCreate. And then we're actually going to create two versions of every function. So for every function that we have, we're going to create one sort of regular version, auth.onCreate, and one for staging. So we're going to append an underscore staging to every single function as well, and make both of these available to ourselves. So if we go back to our code here, and let's go ahead and make that change and sort of see what happens. So I go in here, and we're using Twilio to send an SMS message, and I'm going to update the phone number and commit that out. And if I go over to Cloud Build, hit refresh, there's our new build, and we're going to jump in. So what we're going to do is we're going to do this function called deploy updated functions. So let's look at the Cloud Build and sort of see what's happening here. So you see, again, we're doing the same steps. We're going to use yarn this time to do yarn install. We have some unit tests that we've commented out. So what we're going to do is we're actually going to create a cached version of all the functions that we deploy and put it up in cloud storage. And then every time we do a deployment, we're going to recursively loop over that functions folder, look for changes, and deploy only those files that changed. So we can walk through that a little bit. So the first step is we're going to grab our functions.staging folder from the cloud and look at what functions are currently live in staging. We're then going to do a diff and loop over comparing our local function changes to the changes that are out in staging. We're going to use this .end flag to look for new files as well that we've introduced. And then for each file that's different, we're going to convert that file path to a name again using our camel case convention, and then just deploy that function out, this time to staging. And we're going to pass in our environment variables using KMS again for Twilio. So if we look at our build, see how that's coming along. And we can go down here, we can look at logs, and we can reverse these. So looks like it's deployed, looks like it just finished. And if we go to Cloud Functions, so this is what it looks like when I've deployed all my functions. So for every function that we had, auth on login, auth log out, we have two versions, staging and prod. And if we hit refresh, we'll notice that of the ones that these deployed, only this one, on large scale staging, was updated recently. So we didn't have to deploy any of the other functions. And as you get to scale with hundreds of functions, this becomes really nice. So we just deployed the only one that changed. And if we like how that went, we can go back and, again, do the same thing, merge that into master, and then deploy that out as well. So now this is just going to go ahead and roll out to production. And our CEO will successfully get all text message updates and be able to sort of celebrate our wins with our team. Great. So that's more or less our demo. As a developer, I was able to pretty quickly and easily, in about 10 or 20 minutes, push changes out to Firebase, App Engine, and Cloud Functions with kind of little to no effort outside of just doing a simple git to push deploy. So if we go back to the presentation, this was all done with Cloud Build. And so with Cloud Build, just real quickly, we're going to go through some of the new features that are available today that we used in the demo. It's top level in the Cloud Console, so you'll see it there. We're adding support for first-class artifacts. So the same way that you could push images to container registry, you can now push artifacts to cloud storage. So if we're building things that like binaries or just regular folders. We added support for file path triggers, which we used pretty extensively in order to filter based on subdirectory. And then we have two new changes that are currently in private alpha, but are going to be coming soon. This one is probably the one I'm most excited about, and the one that we hear from customers the most, is a deeper integration with GitHub itself. So we're adding native built-in support for pull requests, posting status back to the new checks API, as well as the ability to programmatically create triggers via the API. So instead of having to go to the UI, if you're creating lots and lots of triggers, you can do it now via the API. And that's all going to be rolling out soon, is available in alpha. And then last is the new result UI that we showed. So why Cloud Build for serverless? It's serverless too, kind of. We didn't really have to provision anything. We didn't really have to think about what it was running on. We just submitted a cloudbuild.yaml file. It's pay as you go. It's a pretty good free tier. It's 120 free minutes a day. The builds, particularly for serverless, were 1 or 2 minutes long, so this is a pretty good deal. It's highly configurable. You can bring your own container. You can run your own tasks. And it's developer friendly. So everything we showed was running in the cloud, but it actually comes with a local binary, cloud build local, so you can run builds on your workstation, and you can trigger builds from API or SDK. So if we go back to our flow diagram here, I think we showed doing a get push through staging, and we were able to use Cloud Build in order to improve your developer velocity and increase faster and safer deployments to serverless runtimes like App Engine, Cloud Functions, and Firebase. Thank you very much.